When we declare an array and specify the size of this array for any base type between square brackets, then we say that this size represents the dimension of the index. An array having more than one index is sometimes useful. For example, the table below that lists the distances between cities can be stored as a two-dimensional array. In this table, the rows and columns are the city names, and the entries represents the distances between these cities. In this table, here are the rows, and here are the columns. In terms of dimensions, we said that the number of rows is the first dimension, and the number of columns is the second dimension. So when we declare an array of two dimensions, then we can represent the data in a tabular form, that the first dimension is the number of rows and the second dimension is the number of columns. Let's take a quick introduction on how to represent this table as a two-dimensional array. Suppose that the name of the array is called distance, and here how we declare two-dimensional arrays, we have two square brackets. The first square bracket is for the first dimension, the number of rows, and the second square bracket represents the number of columns. We have to fill the data row by row. When we want to initialize two-dimensional arrays, this is how we do it. We fill the data row by row. See, for example, this row, it is filled by a one-dimensional array. See, for the second row, it is also filled with another one-dimensional array. So in fact, it is an array of arrays. And this is how we initialize two-dimensional arrays if we have the data in a tabular form. So what is the meaning of a multi-dimensional array and how to declare it? In here, we will show you how to declare and create a multi-dimensional array. You declare a name for a multi-dimensional array and then create the array in basically the same way that you declare and create a one-dimensional array. Remember that for one-dimensional array, when you declare an array, you give it a name, and then you create the object by saying new, and you put the size of the array. For multi-dimensional array, you do exactly the same. You declare a name, and then you create the array using the new command. You simply use as many square brackets as there are indices in the array. So the first square bracket represents the first dimension, the second square bracket represents the second dimension, the third square bracket represents the third dimension, and so on. So this is how syntactically how to define a multi-dimensional array. You put the base type, maybe primitive data types like integer, int, double, float, char, or a class base like a string or a user-defined class. And then you put the square brackets according to the dimension. If you have one, you just put one square brackets. If it is two, two square brackets. And for more, you just put as many square brackets as you want for the dimensions. Followed by the array name, followed by equal, and here now you are creating the array. So you write new and the base type, and then you put the length for each dimension. So this is the length for the first dimension. You put the length for the second dimension until the size of the last dimension, which is n. Here are some examples. Here we have an array of two dimensions of type char. The first dimension is 100 and the second dimension is 80. So this is like a two-dimensional array, so you can visualize this array in a tabular form, that this dimension is the number of rows and this dimension is the number of columns. So here we have 100 rows and we have 80 columns. Another example, an array of type integer, we call it table. Again, it has two dimensions, so if it is a two-dimension, then we can visualize it as a table that the number of rows is equal to 10 and the number of columns is equal to 6. Now in this array, we have a three-dimensional array, which is called a 3D picture. And this is how we create the array. So now we need to have a visualization on how a three-dimension graphically can be visualized. Now, if you have a tabular form, then we say number of rows and number of columns. Now, if you have three dimensions, then we have to visualize it in a different way. And this is what we will show you in the next slide. Finally, for an array of a class-based type, some class, user-defined or a string. Now here again, we have an array of two dimensions. You can represent it as a tabular form, number of rows 100 and number of columns is 80, but each entry in the array is in fact an object of some class type. So here we are assuming that some class is in fact a class. It's not a primitive data type. Next, we will show you how to visualize arrays if we have one-dimensional array, two-dimensional array, and we will show you up to three-dimensional arrays. For more dimensional arrays, then it is sometimes difficult to visualize them graphically. But in terms of arrays, we will show you a way that how a multi-dimensional array is really represented internally inside the memory. Now imagine you have a one-dimensional array that is called array for 5 integers. This is how we visualize it graphically. We assume that it is a line of numbers. We call it sometimes list. And each number has an index. For arrays in Java, the indices starts from 0. So here this is index 0, index 1, index 2. And we know that we have 5 elements, so the last index is 4. Now for two-dimensional arrays, this is how you define two-dimensional arrays. You use two square brackets. The first square bracket is for the first dimension. The second square bracket is for the second dimension. As we said before, that the first dimension represents the number of rows in a tabular form if the data is represented in a tabular form like this table, and the second dimension represents the number of columns. So here we have a table of integers that the number of rows is equal to 4 and the number of columns is equal to 3. So we say that this is a two-dimensional array. So how to reference the indices of this array? Like what we have done for one-dimensional array, each dimension has its own index. It starts from 0. And if we go row by row, now this is row 0. So we go column by column. So this is index 0, 0, 0, 1, and 0, 2. So the row is 0, and the columns goes from 0, 1 up to 2. In the second row, because this is the first dimension, we have two numbers, 1, 0. So 1 belongs to the first dimension and 0 belongs to the second dimension when we talk about indices. So now for this row, row number 1, it is in the first dimension, its index is 1. In the second dimension, its index is 0. And for the next entry, for example, this entry, the index of the row is 1 and the index of the column is 1. Now if we go to the last number here, 3, 2, that means the index of this entry inside the first dimension is a 3 and in the second dimension it is 2. So this is how we reference indices in a tabular form. The first dimension is the row and the second dimension is the column. Now for 3 dimensions, we have 3 square brackets. The first square bracket is for the first dimension. The second square bracket is for the second dimension. And the third square bracket is for the third dimension. Now how to visualize this three-dimensional array? You can visualize it as follows. That the first dimension represents an array of 2 dimensions. So for example, here we have 3. So the first array index 0. And this index 0 is referencing a 2-dimensional array. The second index variable, which is 1 in this array, also pointing to another 2-dimensional array. Or you can visualize them as layers. So this is the first layer, which is 3 layers. And this is the second layers, which is a table. So now as you see now this table, that it is at the lowest level, it is at index 0 of the first array. And the second table is at index 1 of the array. So we say it is at level 1. And then for the next array, which is a 2-dimensional array, it is at level 2. So we say that it is at index 2. So for each table is in fact an array. So this is array 0, this is array 1, array 2, array 3, and array 4. For each array of the first dimension, we have a table. And the number of rows of this table is specified by the second dimension. And the number of columns of this table is specified by the third dimension. So we can look at the 3-dimensional array as a collection of tables, and the first dimension specifies which table. Let's take an example. Suppose we are referencing the element in the array at index 4, 1, 2. So the first dimension is 4, second dimension is 1, third dimension is 2. So first we are locating which table. So the first dimension, it has the index 4. It means we are referring to table number 4. Now here we have the tables. So this is table number 4. And the second dimension, as we said, 1 and 2. So we are referring to row 1 and column 2. So this is array 4, this is row 1, and where is column 2? This is column 2, so this is the entry 412, so we are referring to this element. Another way to visualize the three-dimensional arrays is that the dimensions of the array are the dimensions of the x, y, and z coordinate systems. The first dimension of the array is the value of the x-axis, the second dimension of the array is the value of the y-axis, and finally the third dimension of the array represents the value of the z-axis.